Hello, dear friends and viewers and students. In this video, Dr. Bhatt presents certain notes on alpha carbon chemistry and also details and explanations about alpha carbon chemistry. So, it's here what is we need to understand what is alpha carbon and what is the chemistry behind it. We shall come across points or topics related to enols and enolates. So let us proceed. Here it is. We have to identify alpha carbon atom. Well, what is alpha carbon atom? There has been a system of nomenclature or designating the carbon atom with respect to the functional group in a carbon chain or ring, and that is known as Greek alpha letter system or Greek alphabet system. Accordingly, in a chain with respect to the functional group in a chain of carbon atom, the closest or the nearest carbon is termed as alpha. It is identified as alpha. Next, as beta. And if there are two similar atoms relative to the functional group, as is the case here, we can mark them as alpha or and alpha dash. But both are alpha carbon atoms. Just to differentiate, we can mark them as alpha, one of them, and the other as alpha dash. Subsequently, the next carbon is beta, then after that gamma, and beyond that it is marked as delta. So this is the Greek alphabet system which makes us convenient to distinguish or identify the carbon in a chain of carbon atoms with respect to the functional group. Here you find there is a carbonyl group and two alpha atoms, carbon atoms are there. We can mark them alpha and alpha dash also. Now, if the alpha carbon contains hydrogen linked to it or attached to it, that is known as alpha hydrogen also. So, no problem to identify the alpha carbon atom. Now, next we get to a type of compound which is known as enols. And as the name itself indicates, enol comprises of two terms, two different functional groups, you can say. One is en and the other is all. So, en plus all makes enol. Accordingly, the compound must have a double bond and must have an alcoholic group or OH. So, the enols are nothing but the vinyl alcohol containing vinyl group along with the alcoholic group. And as per IUPAC system, these are known as alkenols. Alkenes bonded with hydroxide group are termed as enols. Here are the examples. Enol, ethanol, depending upon the position of the double bond, it is prop 1 2 all and prop 1 1 all. You can make it out. And the reactivity of enol is lesser than enolates. Of course, we shall get into a term enolate. And here itself I may add that enolate is not a compound. It is a carbon ion. It is an ion negatively charged. And just as carbonate, acetate, etc., this is ATE simply represents that it is an intermediate for many of the compounds, many of the reactions, several reactions. It is rarely taken out or isolated. Now, before we get into more details about enols, let us enolates. Let us get an idea about how enols are derived. Now, enols can easily be derived by taking up or by shifting the hydrogen atom of the alpha carbon atom in a chain with a hydroxyl group. Hydrogen atom shifts from alpha carbon atom to carbonyl oxygen. Enols are formed with loss of water molecule. So it's here you get OH here, and it may be any of the hydrogen can be regarded as alpha hydrogen. In this case, it is OH, isn't it? And so that's how enols are derived. RCOCH3 and one of the hydrogen atom gets attached or shifted to the oxygen atom here, thereby making a double bond between the two carbon atoms, and the oxygen has still two double bonds, one attached with hydrogen and other with oxygen. So, well, that is enol. Then this is the simple chemistry behind enol formation. Now, let us have a look, of course, an exercise here, a practice here. Let us have a look on the following structures for different compounds and infer about the enol formation. Just for an example, I have given you one, two, three. Three examples are there. We have to make out which one will form enol, or all the three will form enol. Mind it, the basic condition is that it must have a alpha carbon atom, and also that carbon atom should be attached to hydrogen, or it should have alpha hydrogen also. So let us see which of them can form enol. Here two carbon atoms are there. With respect to the carbonyl group, one is marked at alpha dash and the other is alpha. As I have already pointed it out to you, if the two carbon atoms are there, two alpha carbon atoms are there, they can be differentiated as alpha and alpha dash. Two different alpha carbon atoms, each containing hydrogen attached to it. Therefore, they can be two separate enols. Two separate enols. Now, how about this one? This is a well-known compound and we call it as formaldehyde or methanol. You don't find any alpha carbon atom here. So the possibility of getting enol is ruled out. And how about the third one? Two alpha carbons are there, alpha dash and alpha. One is linked with the phenyl group and other is linked with no hydrogen. It is linked with alkyl group, methyl group. So two alpha carbon atoms are there, but none of them is attached directly to the hydrogen atom. So no enol is possible. You cannot get enol. Okay, that is how we can get an idea about the formation of enols. Then what are enolates? Enolates are conjugate bases of enols. The functional group here is O negative, if you call it all a functional group. Negatively charged oxygen atom is a enolate ion is the functional group. Or you can call it a functional group. And then the deprotonation of enolizable ketones, aldehyde and esters forms enolates. Enolates are an intermediates. They are seldom isolated. Rather, there is no need to isolate them. And they act as an intermediate in many of the reactions, and therefore it is an ion, negatively charged ion, and here are different type of enolates named according to the IUPAC system. But this ion must be represented here, of course. Here also it should be ion should be added. Propanene 1-olate ion, ethanolate ion, ethanolate ion. All it is an ion. Okay. Then next we get Very important characteristic is about the resonance in ethylene. The deprotonation. Deprotonation means the removal of the proton on alpha carbon atom in a carbonyl compound such as aldehyde. Ketones yield organic anion which is termed as enolate ion. We have already explained about it. And why this occurs? It occurs because of the delocalization of the negative charge to oxygen atom of the carbonyl group, which has double bond. Inductive effect of the carbonyl group, and this represents the resonating structure of the enolate ion, which provides stability to the ion. You see, here one of the electron is shifted to the oxygen atom. Naturally, it becomes negatively charged, and there is a partial charge over here. Oxygen gets a negative charge, so these two structures are there. But none of the structure represents true structure of the enolate ion. Well, that is the characteristic of resonance. Lone pair on carbon forms an electronegative oxygen on the oxygen atom after resonance. So, some note is necessary to be recalled. You should recall, you know it, that through resonating structures, we can provide more than one structure of a particular compound, at least two. It may be more also. But none of the structure represent the true structure of the compound or of the molecule. The molecule is actually in between the resonating structure, and that is known as hybrid structure. So that's there. This has to be recalled. And how enolates ion are derived. It is just example generation of enolate ion through resonating structure. Hydrogen, alpha hydrogen is taken up by the hydroxyl ion, and you get a resonating enolate ion. Taking propanol as the example. In presence of dilute sodium hydroxide, the hydrogen is taken over here, and you get a resonating structure of enolate ion like this. So, thereafter, it is very important that the alpha hydrogen atom has got an acidic character. Alpha hydrogen can easily be withdrawn by a base, such as dilute sodium hydroxide. It can be taken up by a base, and therefore a loss of water molecule is there, and you get a carbon ion, which I've already explained earlier. And these are the resonating structure of providing oxygen and negative ion. And in this case, there is a deep localization of the electron, and carbon ion is produced. So this provides, since hydrogen is available for a hydroxyl ion, therefore we call it as acidic hydrogen. Now, here, when the hydrogen is acidic, how about the carbon? The carbon itself is acidic. The remaining portion is acidic. A lower pK value, it has got its own resonating structure, as I have already explained, and a low and has higher Ka values, just as all acids have their equilibrium constant acid value represented by Ka, and negative logarithm of Ka is known as pKa. So all acids are identified by pKa. pKa is negative logarithm of equilibrium constant for acids, and lower the pKa is stronger is the acid. So this pK value of the acid is represented and depends upon the attached or linked other groups. For example, if OH group is attached, just as in carboxylic acid, RCOOH, pKa is about 5, means sufficiently low, and therefore it is a strong acid. For amides, CONH3 group is attached to the carbonyl group, pKa is 15, formaldehyde 17, and other aldehydes lies between 16 to 18, ketone 19 to 21, and pKa of ester is 25. Well, that is how the acidic nature or acidity of alpha carbon atom can be made out. Okay, thank you. We stop here and we shall get some more details about certain other topic relating to aldol condensation or the carbonyl group. Okay, thank you. We stop here. We shall be back again.